Now here let's continue the same example, but here with this new condition again. It says if the first non-conforming item is found on the 11th inspection, then answer these questions. Because to answer these questions, we really need to differentiate between binomial and negative binomial. I put the definitions of binomial and negative binomial here for us so we can refer to them and make sure we're on the right track. This given fact here is essentially T1 equals to 11, right? The first non-conforming is on the 11th inspection. That's a given information. Now, what is the probability that more than 3 of the first 90 items inspected will be non-conforming? It doesn't ask us to, find the third on the 90th inspections or anything like that. If you look at these two definitions, you see that what is asking here is binomial, number of successes in n trials. 3 successes, in fact, more than 3 successes in 90 trials. So we're looking for probability of n90 being more than 3, given that the first success was found on the 11th trial. Well, if we know that it took us 11 trials to see the first success, now there are 79 to go, 90 minus 11, and we want to see more than 2 successes. That becomes probability of n79 greater than 2. Well, to calculate that, it's better to go with the complement, doing 1 minus probability of n79 less than equal to 2. And to calculate this one is only adding up 3 probabilities. Probability of n79 equals 2 plus probability of n79 equals 1 plus probability of n79 equals 0. That's a lot easier than calculating this one here. To put this more graphically, let's say that you're inspecting these products that are coming out of the line, and every one of these is a product, and it seems like on the 11th you find the first non-conforming. This is the first non-conforming, and you want to know what is the probability of seeing 3 non-conforming in total of 90. Total of 90 starts from here, right? So you keep inspecting, and you really are left with 90 minus 11, 79 inspections. And you want to know what's the probability of seeing more than 2 non-conforming in these 79s, because you already seen 1, so 3 becomes 2. So that's how you approach this. Part H, on average, how many of the first 110 items inspected will be non-conforming? Well, again, looking at these two definitions here, this is binomial. On average, how many successes in 110 trials? Number of successes in n trials. So we're looking for expected value of n 110, given that the first success was on the 11th trial. Well, we know that we already seen 1 success, and that was on the 11th trial. There are 99 more trials to go, and we want to know what's the average number of non-conforming in those 99 trials. So expected value of n99 plus 1, right? And that 1 comes from here, because you already seen 1 non-conforming. So for a fact, the expected value of n110 is going to be more than 1. By how much? By expected value of the remaining 99 trials. And that is NP plus 1. N is 99 times 0.03 plus 1. And that is 3.97. That's the average number of successes in 110 trials given that fact. Moving to part I, what is the property that the third nonconforming item will be found on the 100th inspection? So here you see that it's the number of trials until the rth success. Third is very specific. Negative binomial is very specific. Third nonconforming item will be found on the 100th inspection. So here is probability of T3 be on the 100th inspection, given that T1 is equal to 11. That's actually pretty straightforward. That becomes probability of T2 being equal to 89. If you've already passed through 11th inspection and you found the first one on the 11th, probability of seeing the third one on the 100th is basically seeing the second one since the first one on the 89th. And that is 88, choose 1, times 0.032 times 0.97 to 87. Part J, on average, when will the 8th nonconforming item be found? That's the number of trials until the 8th success. So we're looking for expected value of T8, given that T1 is equal to 11. We know for a fact that it took us 11 trials to see the first nonconforming. So expected value of T8 got to be more than 11. By how much? By expected value of T7. So that is 11 plus R over P, which is 7 over 0.03. That is 244.3. This was a very comprehensive and exhaustive example. I really suggest you guys to go over this example multiple times and digest every one of these sections of this problem and ask your questions.